Let's have a look at question 8b. It says, how long does the weight take to reach the pile? In other words, here is the weight. It's dropped. It accelerates down towards the pile. That's the thing it's banging into the ground. It's probably pointed, by the way, so it makes it go into a bit easier. But it's going to be hammered into the ground, literally. And it takes, we know it starts off at v equals 0. The question, of course, is how long does it take? And actually gives you a hint here. It says, find an expression involving distance. Well, we've got an expression right now involving acceleration. So let's change acceleration into, well, if we integrate it once, we get velocity. If we integrate again, we get distance. So we're going to have to integrate this thing twice. So we know that velocity, then, is the integral of 4.9 with respect to time. So velocity, therefore, is going to be the integral of 4.9 increase the power by 1 divided by the new power plus c. In fact, I don't need the integral sign anymore if I'm going to state all that. Here it is. All right. So now we add in any other things here. C value. Do we have any other information? Yeah, sure. We know that when t equals 0, v equals 0. So if I put v equals 0 and c and t equals 0, let's do it. V equals 0 and t equals 0, then c equals 0 as well. So v, therefore, is 4.9t. And there is our velocity equation. Now, we need to turn that into a distance equation. So s is going to equal the integral of velocity with respect to time, or I could just write the integral of 4.9t with respect to time, which is going to equal 4.9 increase the power by 1 divided by the new power. So that's going to be our equation. So let's take a look and see if there's anything here that can tell us about the distance at the start. Well, no, there isn't, because we're starting at nothing. We're not moving. We haven't moved. Time is 0. We haven't moved. We're going no speed, and acceleration's about to kick in. So this is going to be, again, 4.9 on 2t squared plus c, which is just 4.9 t squared on 2. So we can now say, therefore, based on the question, it says s is 4, and we want to find the distance when s is 4. So we're going to put here when s is 4. So what was the question? It was going to find the what? Find how long? Sorry, we're finding the time when s is 4. Yeah, t equals question mark. So that's nice and easy. We're going to say is 4.9. S is going to be. Sorry, I've done too many of these today. So 4 is 4.9 on 2 t squared. So let's go ahead. So I'm just going to, in fact, I'm going to rewrite that up here so make life a bit easier. So 4 is going to be 4.9 on 2 t squared. So I'm going to multiply both sides by 2. So times by 2 times by 2. So 8 is equal to 4.9 t squared. Both divide both sides by 4.9. There it is. 4.9. 8 divided by 4.9. I think I'm just going to do it on the calculator to make life easier. So here we go. 4.9, and it's 8 divided by 4.9. So 8, 4.9 is 1.63265. 1.63265 is equal to t squared. So I'm just going to take the square root of both sides. So t will equal plus or minus, and I'm just going to go ahead and do that now. So the square root of that would be 1.2775. All right, so that's what we've got. So the time, therefore, we can't have a negative time in this case. It can't happen before it happens. So it's going to be 1 point. I'm going to call that 1.3, and I'm going to say 2 dp. And the time is seconds, so I should put a seconds in between for then. Seconds, and that's 2 dp. There it is. Okay, good. So that is my answer. it's going to take 1.3 seconds or thereabouts. And that's my answer.